All right, let's get started with Lesson 3, States of Matter. In this lesson, we are only going to focus on the basic principles of the 3 states of matter that you're going to be required to know for this class. Later on in the year, we'll get into more specifics and more details on the 3 states of matter that you need to know. So what are these 3 states? You can probably guess what they are from previous classes. You got solids, liquids, and gases. There is a 4th state of matter, the plasma state, but we're not going to really focus much on that in this class because we don't really test on it in IB or AP chemistry. But you do need to know the specifics and the properties of solids, liquids, and gases. Before we get into greater detail into solids, liquids, and gases, I would like to look at the change in states that gases, solids, and liquids undergo, and some definitions that you're probably already familiar with. First of all, I want to remind you that when we change the state of matter from, say, a solid to a liquid or a liquid to a gas, that is a physical change. So I'm going to write that down to remind you that we are discussing physical changes here when we're dealing with the states of matter. All right, melting, you already know, is a solid to a liquid phase change. Freezing is liquid to a solid phase change, and vaporization is, of course, a liquid to a gas phase change. Condensation is when we go from a gas to a liquid, and sublimation is solid to a gas. So in other words, sublimation, we bypass the liquid state altogether, and we go directly from solid to gas change. Deposition is we go from the solid state, from the gas state back to the solid state, and we bypass the liquid state again. All right. So those definitions, make sure you're quite familiar with. All right. Now let's get into some more specific details in the states of matter. And what we're going to do is we're actually going to draw particulate models. Remember that we talked about particulate models in lesson 1. And so now we're going to start applying that idea here to the state of matter. All right. So solid. In the box here, I'm going to draw little circles, and each one of these circles is going to represent a particle that is in the solid state. Now, in the solid state, particles are tightly packed together. They're really super close. All right. Now, I'd kind of write that down in your notes. All right. That's pretty important. So they're solids. The solid particles are tightly packed together in the solid state. Now, why are they packed together? It's for 2 reasons, okay? I'm going to write these down, and you probably should write them in your notes, okay? There are 2 reasons for this. One reason is because of kinetic energy. And the second reason is due to a force of attraction called an electrostatic force. All right, so I'm going to use these 2 concepts, kinetic energy and electrostatic force, to explain the 3 states of matter. Now, solid state, we just said that the particles are in very close packed positions. All right. A reason for that is because the kinetic energy that these particles have is extremely low. Now, solid particles do have kinetic energy. Now, if you recall from other classes, kinetic energy is the energy of motion. All right. So when molecules or compounds or any particle that has kinetic energy, then it allows them to have motion. So these particles that are in the solid phase do have a little bit of motion. It's more of a fixed vibrating motion. They just more or less vibrate in their fixed position. There's not much movement to particles in the solid state. Now, because the kinetic energy is so low for these solid particles, the forces, the attractive forces between particles is really strong. So in the solid state, we have strong forces of attraction. All right. Strong forces of attraction in the solid state. That keeps those solid particles close together in a fixed position, and their motion can be described by vibrations. All right. Now, what happens is when these particles absorb energy, then what's going to happen is that it's going to initiate a change in state, and that would be melting, right? Now, what does it mean to melt these particles? Well, it just simply means that these particles now have more kinetic energy than what they did in the solid state. With more kinetic energy, the attractive forces between the particles is going to weaken. It's going to go down. This will allow the particles in the liquid state to have more freedom of movement. So we have weaker forces of attraction. See if I can traction. All right, weaker forces of attraction, which results in more freedom of movement in the liquid state. Now, when we add even more kinetic energy into the liquid state, then the molecules are going to go through evaporation or vaporization state. All right, and that just simply means that the gas particles are going to have complete freedom to move, and that is because they basically have no forces. Rewrite that. No forces of attraction, or no attractive forces. Okay? No forces of attraction in the gas state. Now, these forces, again, are known as electrostatic forces. All right? So that's kind of the two key ideas to distinguish the three states of matter, is how much kinetic energy they have and their attractive forces. And you can look at it as this, as the kinetic energy. And let me see if I can squeeze this in here. We're going to abbreviate kinetic energy as KE, kinetic energy. As the kinetic energy goes up, then the forces, we'll use F for forces, is going to go down. So the more kinetic energy the particles have, the weaker the electrostatic forces are, and therefore results in more movement of the particles. Now, this concept, the relationship between kinetic energy and the forces of attraction and the movement of these particles, is absolutely vital for you to understand and know. All right? So make sure that you review this very closely and understand it. All right? Now, I'm going to erase some things here. Make some more room for me in the notes here. Okay, so let me rewrite these. Here's our solid particles that are very compact because they have strong electrostatic forces and a little bit of motion. because due to their low kinetic energy. We talked about melting, we talked about vaporization, okay? Now, in the gas state, going backwards, right, going from a gas to a liquid, we refer to that as condensation, right? So I'm going to write in condensation. And condensation just occurs because of the opposite idea here, is that the particles in the gas phase are losing kinetic energy. They're releasing kinetic energy. And as they release kinetic energy then goes down. So if our kinetic energy goes down, then the force of attraction goes up, and the particles then have little freedom, not a lot of freedom, and they become a liquid. Now, if we take away even more energy, then they're going to move from the liquid state back into the solid state, because again, as we lower that kinetic energy, the force of attraction goes up and becomes stronger, and therefore there's less freedom for the particles to move. And this is known as freezing. All right? Now, we can also bypass, erase all of this. We can bypass the solid state and go directly to the gas state, and that is called sublimation. Or we can go from the solid to, or from the gas to the solid, and that's called deposition. All right? So I hope you understand this simple particle model. Remember the key terms, the key things here to understanding what a solid is, what a liquid, and what a gas is the relationship between the kinetic energy that these particles have and the force of attraction. The more kinetic energy particles have, the weaker the force of attraction the particles have. Therefore, the more freedom of movement that will exist between them. All right? Now, the last thing we want to do is I have a table here that I want you to copy down into your study guides. So spend some time going through this. We will use this table in class, as well as it acts as a great study guide to understanding the different properties of solids, liquids, and gases, and much of what we just kind of went through when we modeled the particle model there. All right, so make sure you get this down, study it. We'll also refer to this table later on in the year when we go into more specifics on the three states of matter. But for now, other than copying this table and reviewing that particle model for the quiz, that is all I have for this lecture video.